Okay, we're going to start with number 7 here, which is 2 times r minus 4 over r minus 2. If we simplify that out, we get 2 times r minus 2 over r minus 2, and that cancels, and I'm just left with 2. Okay. Whenever you have a factor with a variable in it on the top and the bottom, and that factor cancels, on the graph that creates a hole. So if your graph looks like this, we'd go over here to r equals 2 and we would put a hole right there. So because those canceled, I know that there is a hole at r equals 2. Okay? So how do I graph this? Well, what does the graph look like? This graph is just the line y equals 2. Right? It simplifies down to y equals 2. So if I go up to y equals 2 and I draw a graph, there is a hole at 2. So on page 3 of your assignment, number 1, you need to draw a or not number 1, we're on number 7. You need to draw a horizontal line at y equals 2, and then at r equals 2, or we could say x equals 2, there is a gap. So the only difference between this graph and this graph is the hole. Give you a second to do that. Okay. Now look at number 8. Number 8 says 45 over 10a minus 10. That simplifies down to 45 over 10 times a minus 1. Okay. So, does this have any holes? Are there any factors on the top and the bottom that are the same? No. So no holes. Okay. The next thing we check for are called vertical asymptotes. So in a lot of these rational functions, there's a line, that the graph gets closer and closer to, but never touches. Okay, those are called vertical asymptotes. A vertical asymptote is created when the bottom has a factor that doesn't cancel. Okay, so in this case, a equals 1 is a vertical asymptote. Okay, now we also have to check if there are any roots. Roots are created when the numerator has a factor that doesn't cancel. So if on top there was a factor a minus 2, then the root would be a equals 2, which means the graph hits the x-axis at 2. Okay, but that didn't happen, so we don't have any roots. Okay, and then most of these graphs have horizontal asymptotes. So there will be some horizontal line that the graph gets closer and closer to. That's not always the case. Number 7 didn't have one. And then sometimes they have a slightly different structure. But most of the time there is a horizontal asymptote. Okay? Horizontal asymptotes are easy to figure out. So you have to look at the original function and see which one has the biggest exponents. Okay? And we're looking at the exponents on the variables. So if the top exponent is equal, well, let's do it this way. If the bottom exponent is bigger than the top exponent, then your HA is at y equals 0. So If the degree of the top is smaller than the degree of the bottom, then your HA is at 0. The bottom is stronger than the top, your HA is at 0, which is what's happening in this case. So the exponent here is a 1, and then the top has no variables at all. So the bottom is stronger than the top, which means the HA is at y equals 0. Okay. What if they're the same size? If the bottom exponent is equivalent in size to the top exponent, then you divide leading terms. What that means is if I have 4x to the 4th plus a whole bunch of stuff divided by 3x to the 4th plus a whole bunch of stuff, I just divide those. And the variables are going to divide out, and the HA would be at y equals 4 over 3. So if the bottom is stronger than the top, the HA is at 0. If the top and the bottom have the same strength, you just divide, and whatever constant you get from that is your HA. Okay. If the top is stronger than the bottom, then we have what's called a slanted asymptote. We'll get to that in a little bit. Okay. All right. So now how do we graph this? Well, we just create all of this information. So on the graph for number 8, we know there is a VA at 1. So I draw that. And I know there is an HA at 0. Okay. So what does the graph look like? Well, there are only two options. Either the graph looks like this and like this, or the graph looks like this and like this. Okay. So how do I know that? Well, I have to be near this asymptote. So I'm going to go over, and as I get over, are there any roots on that side of the graph that allow me to go through the x-axis? No. So as I travel from left to right, I'm only allowed to cross the x-axis when it tells me to. So as I approach that vertical asymptote, I can't go down. I have to go up. And for most vertical asymptotes, if you go up on one side, you go down on the other. So if I go up on this side of the asymptote, then I have to be down on this side. And then as I travel close to the x-axis, I don't have any roots that let me go through the x-axis. So that's what it would look like. That's one possibility. The other possibility would just be the opposite. I would start here and go down and start here and go over. How do I know which one it is? And the answer is you just guess any number. You pick a number and plug it in. Okay? What's the easiest number to plug into a polynomial? 0. But sometimes you can't use 0. If 0 is a whole, you're not allowed to plug 0 in. If 0 is a vertical asymptote, you're not allowed to plug 0 in. But in this case, 0 is neither of those. So I'm going to plug in 0. Okay, I want to know where is the graph here. So I put 0 into this equation. And I get 45 over 0 minus 10, and that's negative 4.5. So which graph is it? The blue one or the yellow one? It's the blue one, right? So at 0, negative 4.5 is the number, so the graph is the blue one. So make sure you draw that. Care what the number was? Did we need to know that it was exactly negative 4.5? No. All I really needed to know is, was this going to be a positive number or a negative number? That would have been enough. Right? Is it above the x-axis or below the x-axis? Okay, let's do another one. Let's do number 11. So v minus 5 over v squared minus 10v plus 25. So v minus 5 over v minus 5 and v minus 5. Okay. Does this have any holes? V equals 5. Right? Okay. Does this have any VAs? Any factor on the bottom that doesn't cancel? 5. Now wait a minute. This wants me to draw a vertical asymptote and a hole in the same place. Which one of those wins? The VA. Can you draw a hole where there is a vertical asymptote? No, there's no graph. So the VA actually wins. Okay. And what about roots? Does this have any roots? No. Okay, what about HA? The top is weaker than the bottom, so the HA is at y equals 0. So we graph this. Over here at 5, we have a VA, and we have an HA at 0. Okay, and then we have two choices. It's either going to look like that and like that, or this and this. How do we figure out which one it is? Guess. What's the easiest number to plug in? 0. And we don't really care what the answer is. All we need to know is, at 0, is it positive or is it negative? So if I cross those off, because I plug in 0, negative 5 over 25 is a negative number. So it's going to be the blue graph. Does that make sense? Okay. Look at number 12. X plus 6 over x squared plus 5x minus 6. So that is x plus 6 over x plus 6 times x minus 1. So there is a hole at x equals negative 6. There is a VA at x equals 1. When I look for roots, I get none. When I look for HAs, I get y equals 0. The bottom is stronger than the top, so the HA is 0. Everybody good with that? Okay. So at negative 6, I have, oh no, I did that wrong. I'm sorry. My VA is at 1. Okay. And I need to know, is it this graph and this graph? Or is it this graph and that graph? Well, I just need to plug in a number. 0 is the easiest case. Am I allowed to plug in 0 here? Yes, because it's not a VA and it's not a hole. So I plug in 0, and I get a negative number. So the graph at 0 is a negative number, which means it has to look like this. But I forgot something, the hole. So over at -6, I draw a hole. Okay. Let's do some that are a little bit harder. Let's do 14. Did I do that right? Oh, no. No, definitely not. 10 and 3. Sorry. I don't know what I was thinking. All right. Does this have any holes? V equals -3. Does this have any VAs? So that is the hole. This is the VA. Does it have any roots? V equals 10. What about HA? Well, the bottom and the top are the same strength. So we divide those, and I get 1. So Y equals 1 is the HA. Okay. So let's draw this graph. So I have a hole at -3, and I have a VA at 8. Your graph is numbered. Oh, it goes up far enough. Okay, good. All right. And we have a root at 10. So we are going to cross the x-axis right there. Okay. And I have an HA at 1. So my two possibilities for graphs have to hit the x-axis at 10. So in this case, I don't even need to plug anything in. It has to be the other graph. That's the only way for this to work. So this is the equation. Okay. All right, let's go back to the beginning and do number 1. So 36x to the third, negative 36x to the third over 42x squared. So that simplifies down to -6x over 7. And we have a hole at x equals 0. We have no VAs. We have a root at x equals 0. And we do not have an HA. Okay. So if the top is stronger than the bottom, then you have a slanted asymptote. A slanted asymptote. Okay. But on these simple problems where you have a monomial divided by a monomial, This is your graph. But how do I deal with the fact that it has a hole and a root in the same place? Which one wins? If you tried to graph a hole and a root in the same place, the hole's going to win, right? The root says we're going to hit the x-axis right here, and the hole says no, there's a gap right there, so you miss the x-axis. So when a root and a hole fight it out, a hole wins. When a vertical asymptote and a hole fight it out, the vertical asymptote wins. So this graph is simply this. The y-intercept is 0, the slope is -6/7, but there is a hole at 0. Okay. So on 1 through 6, all you're going to do is graph the simplified equation, which is just going to be a line, or, well, not necessarily. So let's look at number 2. Number 2 is 16r squared over 16r to the third. So this says we have a hole at r equals 0, but we also have a VA at r equals 0. Which one of those wins? The VA wins, the hole loses. And this has an HA at bottom is bigger than the top, so we have an HA at 0. So when I graph this, HA at 0, VA at 0. So it's either going to be this graph and this graph, or this graph and that graph. How am I going to figure that out? Plug in a number. Can I plug in 0? No. 0 is a vertical asymptote, so we can't plug it in. We could plug it in. We're just going to get 0 over 0, which isn't a conundrum. So I need to plug in any number other than 0. So let's try 1. 16 times 1 squared over 16 times 1 to the third is 16 over 16, which is a positive number. So the graph looks like this. Okay. Do you kind of have the hang of this? Let's do 22. 22 says x to the third minus x squared minus 42x over 2x squared minus 20x plus 42. So x times x minus 7 times x plus 6, and 2 times x minus 7 times x minus 3. Everybody good there? Does this have any holes? X equals 7. Does this have any VAs? X equals 3. Does this have any roots? Zero and -6. Does this have an HA? No, the top is bigger than the bottom. So it's not an HA, it's an SA, a slanted asymptote. Okay, now every slanted asymptote comes with an equation, a linear equation, slope-intercept form, y equals mx plus b. So we need to figure out where that slanted asymptote is. And here's what you do. You just do division. And it's kind of a pain. But I'm going to put 2x squared minus 20x plus 42 on the left side of the box. And then I'm going to do division. Okay? The nice thing about the division is all you need is this. You don't need to go any further than that, because all of the other stuff will build a remainder, and the remainder doesn't matter for a slanted asymptote. So we put in x to the third, and this is going to be a little weird. What times 2x squared is x to the third? Some number times 2x squared is x to the third. It's going to be x over 2, or 1/2 x. So 1/2 x. Does everybody get that? Okay. Now 1/2 x times negative 20x is negative 10x. I don't need this box. That box is going to help me build a remainder, and I don't care what the remainder is, so I'm not going to fill it out. Okay. These two boxes need to add to be negative x squared. So I have negative 10x. I need to add that should be squared. I need to add 9x squared. Okay? And then what times 2x squared is 9x squared? Would be 9 over 2. 9 over 2 times 2x squared is 9x squared. So this is plus 9 over 2, which is 4.5. That is my slant asymptote. Y equals 1/2 x plus 4.5. Okay. Any questions about that? Do you think you guys can recreate that? So if the top is bigger than the bottom, then you have a slanted asymptote. To find the slanted asymptote, just do division, but you only have to do part of the division and then you can stop. You don't have to finish it out. But slanted asymptotes actually only occur when the top has one more x than the bottom. What if the top had 2 more x's than the bottom? Then you'd have a quadratic asymptote. So you'd have a dotted line that is in the shape of a parabola, but you're not going to see any of those. Okay, now it's time to graph. VA at 3. Okay, I have roots at 0 and at negative 6. Okay, I have a slanted asymptote at 1/2 x plus 4.5. So I go up to 4.5, and I have a slope of 1/2. Okay. So what does that graph look like? Well, it either looks like this or like this. Which one is it? It's got to be the second one, because I have to hit those 2 roots. Okay. All right. Think you can handle that? Get to work.